Hey physics students, welcome. We are going to talk today about introduction to acceleration, what acceleration is, and how to calculate an average acceleration. In the last video we talked about speed and velocity, how to calculate those, and this kind of is right in the next step into talking about motion and describing motion. So, acceleration is defined as the rate at which an object changes velocity. So, and basically in simpler terms, it's how fast an object is speeding up or slowing down, or not at all, if it's just moving at the same sort of pace. It's it's a quantity describing how fast an object speeds up or slows down. So, couple of examples here. I have some time data and I also have velocity data. So, in this first example, we have time 0, 1, 2, 3, 4. What do we notice is happening with these numbers? What's happening to the velocity? Well, if you said it's getting bigger, you're absolutely correct. As time goes on, 0 seconds, we're at 0 meters per second. Then at 1 second, we're at 4 meters per second, then 8 meters per second, then 12, then 16. And so by this data, you can see that our velocity is increasing by 4 every single second. We'll get more into that when we talk about calculating velocity, but just notice when you look at this data that the velocity is increasing, and that we know we're getting faster and faster because our numbers are bigger and bigger. In this example, as time goes on, what do we notice is happening to the velocity? Well, if you said it's staying the same, you're absolutely correct. In this example, our velocity is constant. We call this a constant velocity, meaning we have an acceleration of 0. So a key thing, if velocity does not change, our acceleration is 0. So if velocity does not change, acceleration is 0. When we write 0, do we need a unit? If you said yes, you're wrong. If you said no, you're correct. The reason 0 does not need a unit is because it's 0. There is nothing, nada, zilch. There's nothing. There's nothing to describe. There's 0. There's 0 cats. There's 0 dogs. There's 0 sheep. There's 0 velocity. There's 0 anything. There's just 0. So 0 does not need a unit. It could be good to describe if you're reporting in a scientific paper and your answer for a answer is 0. You could report what quantity you're analyzing, so people reading understand. But just note, if velocity does not change, that's a horrible start. A little bit better. I am a terrible drawer. You will get used to it. So, if velocity does not change, acceleration is 0. Alright, let's move on and talk quickly about calculating the average acceleration of an object. So, calculating average acceleration is defined as our change in velocity. Remember, this triangle symbol just means change. So change in velocity divided by our change in time. So here's a bunch of symbols. If this is confusing, it just means our final velocity, so what we end with, minus what we started with, our initial velocity, divided by our final time, divided by our initial time. So change is always defined as the final quantity minus the initial quantity, right? If I start with 30 gumballs, and then you all students come to class and you give me more gumballs, and I end up at the end of the day with 30 more gumballs? Well, my change, let's see, 30, I started with 30, I end with 60, so doing the change of this, we'd have 60 minus 30 gum, I don't have room there, and we have 30 gumballs. That is how I would calculate the change. That change, I have now added 30 gumballs to my supply by the end of the day. So let's do a quick example, just a basic calculation on average acceleration. So we have a sports car. It starts at the start line. It is at rest. When I say at rest, I mean 0. 0 meters per second, 0 miles per hour, 0. And it reaches 30 meters per second in 5 seconds. So let's go ahead and calculate that average acceleration. So A is the symbol for acceleration. So if you're in your formulas, you just write A, that's the symbol for acceleration. Acceleration equals change in velocity. V is also the symbol for velocity. We haven't talked about that yet. Divided by our change in time. T is the symbol for time. Equals, so change is my final velocity minus my initial velocity. So my final velocity is 30 meters per second. I end up going 30 meters per second. So 30 meters per second minus 0 meters per second. That's what I started with. Divided by, well, our time final, it says in 5 seconds. Well, what's our starting time? Typically in most physics problems, unless I say otherwise, we can start all of our problems at 0 seconds. It's convenient, it's easy, it's less math. So starting your problems at 0 seconds makes the most sense. So we have 5 seconds minus 0 seconds. That's going to by our change. So we have 30 divided by 5. And we end up with 6. Well, 6 what? What are our units of acceleration? I want you to think to yourselves, maybe some of you already know this, but think, pause the video, see what you can come up with units for acceleration. Right, so I want to walk through, again, just like we did in the last video with finding the units for velocity or speed, we're going to take our units that are in the top and divide by our units in the bottom. So we have meters per second over seconds. Well, that's confusing. I have meters per second? Well, let's dig into that a little bit. Why this makes sense, or why this should make sense, is we're talking about the rate of change of speed, of velocity. And so think back to what we talked about when we talked about velocity. We said velocity is a rate of change of position. And when I explained velocity, I said 30 meters per second means I travel 30 meters every second I'm traveling. So if or let's say 2 meters per second. Here, I'm walking 2 meters every single second I travel. This is a rate of change of velocity. This quantity right here means that we are gaining 6 meters per second, so we're speeding up 6 meters per second every second we're going. So we have a constant acceleration. We're accelerating or getting faster 6 meters per second every second. Some other units. This is definitely the most common unit of acceleration. We could have miles per hour per second. We could have meters per second per hour. For maybe a glacier or a big sheet of ice that moves very slowly, we could have centimeter, actually that probably wouldn't have, we could have centimeters per second per year. All of those are acceptable quantities. We'll definitely be working mostly in this unit. Also, I want to mention acceleration is a vector. In the next video, we're going to talk about acceleration vectors, which direction they should point depending on the situation, and you'll understand a little bit better about which direction the acceleration points, but it is very important that acceleration does have a vector. In this example, I do not have one. We'll get to that in the next video. Thank you for watching. Have a wonderful rest of your day.